In this lesson on logarithms, we're going to talk about ways to solve exponential equations not requiring logarithms. Now remember, part of the reason for logs in the first place is to solve for an unknown that's an exponent. In this case, I give you an example where y is an exponent. We don't know what it is, and we can't, just by guess and check, come to an exact value. So we're going to use logarithms to find out that value. And just as a refresher, if I were to rewrite this using logs, I would write log base 3 of 10 is equal to y. And this is known as logarithmic or log form. And the top equation is known as exponential form. And both 3y is equal to 10 in exponential form and log base 3 of 10 is equal to y are the same equations. They're just written differently. Now let's talk more specifically about solving exponential equations not requiring logs. And there's a trick or a secret or a method of figuring out values of exponents that are unknown. So let me give you an example of what you want to try to accomplish as part of the process of solving for an unknown exponent. In this case, I give you an example. 3x times 3 squared is equal to 3 to the 4th. Now, I know that 3 squared is 9, and I can figure out that 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81. I know that this value here has to equal 9, and that therefore x is going to be equal to 2. So I have 3 squared times 3 squared is equal to 81. Now if you remember, as we discussed exponents several months ago, we learned about the product of powers property of exponents. And that said that a to the n times a to the m, as in Mary, is equal to a to the n plus m. And we're going to use that property now to solve for variables as exponents. And the strategy here is to create bases, in this case the base would be 3, that are all equal. Once we have bases that are all equal, in this case a, and a, we can ignore these values to solve for the variable as the exponent. So in this case, we really don't need to know that this is 3, or this is 3, or this is 3, once all the bases are the same. Because the equation to solve for x just becomes x, this x value, plus 2, remember we're adding them as exponents, is equal to 4. And then we can figure out then that x is equal to 2. So the strategy is, let's create bases that are equal, and then we ignore the bases for the time being to solve for the exponents. So let's take a problem from your homework, and we're going to take number 11. Number 11 is 10 to the negative 3x times 10 to the x is equal to 10 to the negative 1. So again, the strategy here is to create all bases that are the same, and in this case they are all the same. So we can just set up our equation as negative 3x, now plus x is equal to negative 1, and solve for x. So this becomes negative 2x is equal to negative 1, and x is equal to 1 over 2. Now things get a little bit more complicated when the bases are not the same. So let's take a problem again from your homework, number 22. In this case, we have two different bases, 243, 9, and 9. And our strategy here is to figure out a way to make all the bases the same so that we can ignore them and just solve for the exponents. So what I want to do is I want to change 243 into a value for 9. But I want that 9, the value of the base of 9, also to equal 243. Well, as I think about it, I know 9 times 9 is 81, times 9 again is 729. And I'm not sure if I can reduce this by taking the cubed root of 243. The cubed root of 243 is not equal to 9. So this becomes a little bit more complicated. As I look at this further, I see that 243 to the fifth root is going to be 3, and that 3 squared is going to be 9. So I can rewrite 243 in terms of 9, but I need to handle this in two separate processes. The first is I need to reduce 243 to 3, and then I need to square 3 to make it 9. So if I take 243 to the third, I'm taking it to the fifth power. And if I then square it, then I have 9. Now, in this case, we're going to work backwards because I want to first take the square root of 9, which is the square root of 3. I'm sorry, the square root of 9, which is 3. And then once I have 3, I want to take it to the fifth root, which is 243. So this value here, 9 to the 5 halves, is equal to 243. So I can rewrite 243 in terms of 9 by adjusting the exponent here from 1 to 5 halves. So what I'm going to do is I'm going to write this as 9 to the 5 halves. And remember, I'm still multiplying this by k plus 2 times 9 to the 2k minus 1 is equal to 9, which is the same as 9 to the 1. So now that I have my bases the same, the rest is pretty straightforward. And it's simple algebra. I have 5 halves k plus 2 plus, remembering the product property of exponents, 2k minus 1 is equal to 1. Or I have 2.5k plus 5 plus 2k minus 1 is equal to 1. Or I have 4.5k is equal to, I have 5 minus 1, which is 4. And I subtract 4 from both sides, I have negative 3. K is equal to negative 3 over 4.5, which is the same thing as negative 2 over 3. So remember, when we have a fraction, we want to make sure that the final answer that we give for that fraction has whole numbers in both the numerator and the denominator.